Thank you very much. Good afternoon, everybody. Thank you very much for coming up in so many numbers. Really appreciate that. Looks like Sonic is getting popularity as we were expecting. You know, it's a famous saying that you cannot manage that you cannot measure. And certainly, you cannot measure what you do not see. So that is why, when it comes to network management, good monitoring and telemetry is of paramount importance. My name is Kamran Naqvi. I'm principal architect at Broadcom. And today I'm going to talk about some of the very interesting silicon-enabled telemetry feature that we have in Broadcom Silicon. And I will also show you a live demo of one of those features through an open source collector that we have developed. These silicon-enabled telemetry features that I'm going to talk about, these are the features that we developed for our mega-scaler customers. And they've been using it for a long time. And what we are doing is we are exposing all these silicon-enabled telemetry features through Sonic for all our enterprise customers. So we are democratizing open networking for everyone. The benefits which were at one time only specific to mega-scalers should be available to everyone. So these are the features. Well, there are multiple features. There are more than 3 features in Broadcom Silicon. I'm just going to introduce these 3 today. So the first one is in-band flow analytics, or IFA. In-band flow analytics is a feature that can give you hop-by-hop latency of every packet of a flow at a nanosecond accuracy. So I repeat, hop-by-hop latency of every packet of an interesting flow that you define at a nanosecond accuracy. So this is the type of feature which can very quickly tell you whether or not an application performance issue is caused by the network or it is not caused by the network. Yeah, let's face it. We are all networking people sitting here. If there is any problem in your data center, who is the first team to be blamed? Yeah, welcome to our world. It's us, right? And it's so much so, we say that we are guilty until proven innocent, right? It's the other way around for us. And that is why the networking people came up with this term, mean time to innocence, MTTI, right? How quickly I can prove that I am innocent, right? So that's what I say. IFA is a type of feature that can really improve your MTTI because very quickly you can tell if there is a problem in the application, whether it or not it is caused by network. And why I'm saying that, I'm not going to too much in detail in IFA. I just want to give you one important point about IFA. Maybe in the next session or next OCP we can talk more about it. Why it is important? Because in IFA we are not measuring latency using synthetic traffic. It is in-band flow. We are measuring the latency on the actual application traffic. As your application packet traverses through the switching fabric, we are adding our headers, and then we are stripping them off at the end. So, because we are talking about here ECMP type network. If you are using synthetic traffic, there is always a question whether the measurement that you were doing, were using a different path, and your actual application traffic was going through a different path. Does it make sense? Yeah. With IFA, there is no ambiguity. What you see is what is being observed by the application. So that is why it is very powerful, very popular feature with the mega scalers that we are exposing through Sonic for everyone. Buffer statistics, congestion monitoring. So this is a feature which can allow you to monitor buffer utilization directly from silicon. So this is a feature, what we see is people use in 2 different ways. One way is some of our mega scalers are using this feature already, and the way they use it is they use buffer statistics feature to build a heat map of the network. So they can look at their topology and they can understand which switches, which routers are running hot in terms of buffers. Does it make sense? Yeah. And the way they use it is, because this information is very valuable, what they do is, when they look at this topology, they look at the heat map and they see, okay, this area is really utilizing high buffer, which means there's a high likelihood of congestion, which means there's a likelihood of packet drop. And what they do is they do traffic engineering and move their business critical application away from that red hot area, right? So that's one use case. The other use case is it is used as a threshold, as a watermark. So you can understand that particular switch, for example, is running really hot. So you understand it's like a proactive notification for you that congestion is going to happen and packet drops may start happening. So that's another feature. And finally, my favorite of three, mirror on drop or mod. So mod is a feature which provides real-time packet drop monitoring for your business critical application. And what are your business critical application? We don't know. You define. So in mod, you define which flows are important for you, and mod will monitor them. But before I talk more about mod, just very quickly, why packet drop matters, why it is important. Because packet drops can have a very negative impact on your user experience, right? Your users may be using voice over IP. What will happen if there is packet drop? Their audio will become choppy. If they are watching video, it will continue to pause, right? If there is they're doing shopping, their experience will freeze. And packet drop monitoring, packet drop is not an easy problem to solve, is it? Because typically, there are number of hops between your user and the actual application. And then there can be number of reasons why packet drop is happening. It is not that simple. It could be happening because of protocol failure. It could be happening because of misconfiguration, human error. It could be happening because of congestion or a DOS attack. So packet drop remains one of the most elusive problem to triage and troubleshoot. Well, I said remain most elusive. I should say was most elusive, because in comes mirror on drop. Mirror on drop can really reduce your root cause analysis time, can get you to the root cause very quickly. How? Because it simplifies your packet drop monitoring. Mirror on drop can monitor your business critical application that you define, and it gives you where, who, what, and why of packet drops. How does it work? So what happens is, when any packet drop happen in the traffic that you defined, the silicon is going to make a copy of that packet. So that's why we say mirror. So it mirror the packet, make a copy of the packet, and it sends that packet to a collector, right? Now, obviously, this copy of the packet contains the metadata information. It contains all the header information, source address, destination address, port number, etc. So looking at that, very quickly, your operations team will understand what application is impacted. They will also understand source destination address, right? So they will understand which user group is impacted, where the traffic was going. And then this mod information also contains the switch identifier. So they will understand where the packet drop is happening. Does it make sense? So very quickly, when the first packet drop happened, your operations team understand what is impacted, who is impacted, where the impact is, and then probably the most intelligent thing, why it is happening. Mod gives you a drop reason. So because just when silicon dropped the traffic, silicon understand why it dropped the traffic, right? Drop the packet. So the drop reason could be a missing VLAN. It could be a VXLAN translation error. It could be a hardware misprogramming error. It could be really complicated error. Silicon is giving you the precise reason why it is being dropped. Our latest silicon, Tomahawk 5, has close to 150 drop reasons. So we give you a very accurate, very precise reason why a packet drop happened. You understand the root cause of the problem. Does it make sense? Yeah. So if you think about it, even before your user started complaining about an issue, and let's face it, in many of the cases, our operations team only know about a problem when the users start complaining about it. In this case, even before users started complaining about the issue, your operations team know that this business critical application is having issues, where the issue is happening, on which switch this is happening, and why it is happening. If it is missing VLAN, they will go configure the VLAN and the issue resolved. Very powerful feature. Won't you agree with that? Yeah. But the good doesn't stop there because in case of mod, it is a stateful feature. What is the benefit? Well, a flow may contain thousands of packets. We are not going to inundate your collector with thousands of messages that this drop is happening. With mirror on drop, we will only send you one message. Packet drop is happening on this, and all the information that I just talked about, right? And then one message, packet drop has stopped. So once again, a very solid feature which is not inundating your collector with useless information. It's giving you very precise, actionable insight that you can use to very quickly troubleshoot the issue. We understand it is a very valuable feature, so we continue to invest and innovate on this feature. Innovation is the key thing for us at Broadcom. So we are increasing the breadth of coverage. The initial version of mod, they only monitor packet drop in the ingress pipeline. Tomahawk 5 not only monitor packet drop in ingress pipeline, we can do it at egress pipeline at an MMU level as well. The second thing, we are also increasing the number of drops. So when we started off with 10 to 15 most popular drops, today we support close to 150 drop reasons. And we continue to work with our ecosystem partner to develop more commercial and open source based collectors. So when we talk about commercial options, there is a very good solution from Broadcom called NetOps. You can use that for mod. You may have heard about Octera. There are other partners who are providing these commercial versions where you can use mod. But today, at OCP here, I am presenting to you an open source collector that we developed at Broadcom. It is still in beta version, but within a month or so, we are going to upstream it. It will be available publicly. This is what you see in the middle of this slide. This is the graphical representation of the open source collector that I was talking about. And there are plans to integrate this open source collector with Moon soon as well, and we are working with Kamal for that. You can see it comprises 4 modules. As you can imagine, all of these are open source. So we are using Grafana for visualization. We are using InfluxDB as our database. We are using Telegraph as our data collection agent. And this Packet RX app, this is an input plugin for Telegraph. So this input plugin basically tells Telegraph how to decode mod message and how to understand the various metrics provided. We also updated the egress plugin for Telegraph as well. So we not only this Telegraph now can do metric write operation, it can also do metric read operation, metric update operation, and metric delete operation. We're not doing much with InfluxDB. We didn't add any soft code there. We just created our tables. And with Grafana, we created a dashboard that I'm going to show you in a minute. Any questions so far? Okay. You've got a, yeah. Yep. Very good question. So the question was, you are doing all these monitoring things. You are, measuring the latency with the IFA feature that I talked about first. Here you are doing this packet drop monitoring. Is there any impact to the performance of the silicon? Right? This is a very good question because I come from a different company. I joined Broadcom 3 years ago. Before that, I worked for some other company. There were lots of feature on the router, right? I was part of the professional services. I had like hundreds of features. And when a customer asked me, can I use this feature? I would say, yes, you can. Performance will come down by 50%. Performance will come down by 40%. We have all been there, right? Without naming anybody, this has been a general practice. One thing that I love about Broadcom, and not just because I'm Broadcom now, is that these are silicon-enabled features. So I asked the same question that the gentleman asked here. When I first joined Broadcom, I was sitting with a distinguished engineer. He was explaining this, silicon-enabled telemetry to me. I said, okay, it's just Broadcom. It's an internal discussion. You were saying there is no performance impact. Let's face it, come on. A packet is going without latency measurement, and a packet is going with latency measurement. How can it be the same? Doesn't make sense, does it? Right? And then he explained something to me, which I never understood before. So his first answer was, because it is built in pipeline. And I was like, okay, but what does it mean? I don't understand. And then he explained to me with an example. He said, we were sitting in a conference room. So he said, when we build a feature in the pipeline, it is like this. So imagine this, all these chairs here. This is our pipeline. Yeah? When we build a feature in the pipeline, it means that when a packet comes in, it will be sitting on every chair. Now, IFA is one of those chairs. Whether or not you are using IFA, packet is going to sit on that chair. Right? So when we've built a feature in the pipeline, it means that there will be zero impact on the performance when you use that feature. You use that feature or you don't.
The feature is hardware-based. Is that the...
Exactly.
Okay.
Exactly. All right. Yeah, so hardware-based is another way of describing this. This is built in the pipeline. All right. So we're moving to the configuration side, and then I'm going to show you the demo. I'm not going to talk about, walk you through all that configuration. This is the Sonic configuration. Just 1 or 2 bullet points. How we are going with the time? I've got 9 minutes. All right. So you define the switch identifier, very important, because this is what you will get with the mod message. Collector, so that is where you're defining where is your collector, your IP, and it listens on UDP port number 2055. Flow group, probably that is the most important thing, right? Flow group is where you're defining your interesting traffic. Here you're defining your business critical application. How you can define it? Very, makes sense. You can just use layer 3 parameters. You can use layer 4 parameters, IP addresses, port number. But you can also use layer 2 parameters. You can use MAC addresses, you can use VLAN ID, you can use Ether ID, Ether type. So there is a lot of flexibility in how you can define your interesting traffic. And in the final, this session command, that is where everything comes together. You are saying, I want to monitor this interesting traffic that I defined, and I want you to, if there is a packet drop, send it to this particular collector at this rate. So it could be sampled, it could be that you send every packet. All right, which takes me to the demo. Now that is the tricky part because it is a real demo on actual switches, which are sitting in Cambridge. I'm going to access them from here. So Murphy's law apply when it comes to live demos. If it can go wrong, it will go wrong. Hopefully it doesn't. So just the reason why I was not sitting here with everyone else, because I was trying to fix something. Before I came here, there was something broken. So I think I fixed it. Let's see, we'll find out. My wife was saying, she's a PhD, she was saying there's 88% chances that it will fail if you do live. I said, I'm an engineer, I'll take my chances. And I have fellow engineers as well, so if it is broken, we'll fix it together if we have time. 7 minutes. Is it time overtime or 7 minutes okay? All right, okay. You can still see my screen. Right, so dashboard. So this is the Grafana dashboard I was talking about. This drop anomaly percentage that you see here, this drop anomaly percentage is basically the number of drops observed compared to your baseline. And your baseline is the number of drops over a defined period of time. That will be calculated. Obviously, it's a demo. So I just restarted it because it was broken. So there is no baseline here. But you can define the period. So you can see the period could be 5 minutes from this drop-down menu, or it could be, I don't know, 5 year, 1 year, what, yeah. So it can go up to 5 years. So that's your drop anomaly percentage. Total switches reporting drops. So I'm only using one switch. So it will be one we start, if it works. And then total active drops. So how many flows are being dropped, that will be shown here. So I'm hoping to show you 2 drops. I'll be generating 2 flows, which will be dropped for different reasons. And I'll explain that. And current drops, I'm going to talk you through once we get to that point. Okay, so this is our collector. This is let me show you the switch. So this is a switch. Go to Sonic CLI, show version. So you can see this is the real switch. It's an edge core 7326 switch. I'll quickly show you the configuration as well. Is it big enough or too small? I don't think you can see that. I'll zoom in. Shurantam. Is this better? Yeah, so you can see it's very similar configuration to what I was showing you. So in case you can't see it, it's the same configuration as you saw on the slide. One thing to point out is that the switch ID that you define on Sonic, it's numeric, it's decimal. What you will see in the mod message and when it is on the collector, it will be in hexadecimal format. So it says 44444, and hopefully someone can calculate it for me. It will be in hexadecimal, but that is what we will see in the collector. Okay? So what I'm going to do is I've got two flows defined. My first flow is where I will be sending some traffic, which is, yes, from here. Now this is the traffic. You probably can't see, but what it is, it's the source IP is equal to destination IP. Now what type of traffic it is? It is a dodgy traffic, right? This is the definition of a DOS attack. Source IP is equal to destination IP. So should Silicon allow it and let it go? Answer is no. Silicon is going to say source IP equal to destination IP. This is the well-known definition of an attack. An attack is happening, and I'm going to drop that traffic. Make sense? Yeah? And hopefully when the packet drop happens, because this flow is an interesting flow, in my configuration, we will see mod message is sent, and hopefully on the collector, we will see one flow is being dropped. So it is being sent. Look at the collector, and bingo, it is working. One active drop, and one switch is reporting it, and drop anomaly percentage will change because we don't have a baseline here. This is the information that your operations team will see. This is the switch ID. So AD9C, this is the hex number. Source IP and destination IP, can you see that? It's the same. And if I scroll to the right, you will see that drop reason is what you can see here. It's a DOS attack. Yeah? All right, let's send the second traffic, which is probably more interesting. There is nothing wrong with this traffic that I'm sending now. Yeah? The only thing is I'm sending the traffic for a VLAN that I have not configured on the switch. Can this happen? Yes, it can happen, right? It's a human error, right? You didn't configure something somewhere. So it's a missing configuration thing, not easy to troubleshoot that packets are being dropped. You've got 1,000 switches, right? You don't know where the packet drop is happening, why it is happening. But with mod, you will see. We're going to send this traffic here. And fingers crossed. There you go. 2 active drops. Can you see that? And you can see unknown VLAN ID. Can you see the drop reason on the top? Unknown VLAN ID. Yeah? So it can tell you exactly, and as you can imagine, if I go on the left, this dashboard looks good. Trust me, at the moment I'm going through a backup route into my lab because something else is broken as well. So usually this dashboard is quite easy to read. You don't have to go left and right. So you can see that switch ID, you can understand the drop reason. So your operations team will look at this. Okay, packet drop is happening, this source, this destination, this port number. Okay, so this application is impacted, packet drop is happening on this particular switch. This is the reason why. And they can quickly go back there and fix it. Hopefully it makes sense. Thank you very much. Any questions?
Hi, Kamran. Just one question. So the collector, or the way you are able to capture the information, we understand is in hardware, but the data is then exported to an outside collector, and you said Influx and Grafana. Do you or any of your partner provide an easy to install solution, or is it left to us to just figure it out how to install all of this for ourselves?
So for this open source collector, at the moment there is nobody who can go and configure it for you. The commercial solution like NetOps, if you buy from Broadcom, there is help. If you buy it from Augtera, there is help. So there are other ecosystem partners who can give you that.
Okay, so if I understand correctly, those more commercial solutions use this way of collecting the data.
Correct.
Okay, understand. Thank you.
Okay. Sorry, I didn't mention only easy questions are allowed.
Yes, thank you for the nice presentation. Which hardware is supported? So you said it's a pipeline feature in hardware. So if I have a very old, let's say Trident 2, I assume it's not working. What is
Trident 3 supports it. From Trident 3 onwards, it is supported.
Oh, okay, nice. Thank you.
I think Trident 3 is probably the most prevalent one. Would you agree? The mode, yeah. Tomahawk also supported it. So Trident 3, Tomahawk, and so on. Number of the feature is implemented in the same way from a user point of view. But number of drop reasons improve, the number of drop reasons improve, and where we can monitor that improves. Okay, I'm already over time, so if there is no more question, thank you very much for your time. Appreciate it.